short lesson on calculus. We'll be dealing with special limit. In this case, is a limit of sine of h over h as h goes to 0. The quick answer to this is s equal to 1. Okay. Uh, I'll be talking about two different ways in which we could try to understand why that must be true. Let's try to look at this particular shape. As we know, the sine of h is actually the y-coordinate of a unit circle, which is this one right here. That's the height, right? That height right there. The h, you could think of h here as a theta, right? If this central angle is a theta, this being the unit circle, that length is also theta. So all we are actually comparing is the arc length of the unit circle. Let's say if you call this point P at point P at point P. So we're comparing from here to here versus here. So if you sort of think about that for a second, guys, right? You could clearly see that when you're comparing this to this, right? Clearly the arc length is longer. But as the angle decreases, what happens to the height over here, guys? They're pretty close to each other, aren't they? Right? So especially as the h decreases right there, this comes to 1. Okay. So that is the intuitive approach to understanding the limit of h over h as h goes to 0. Let's approach, let's try a different approach. Here's a geometric approach. And this picture over here is the key. So we got this triangle and we have this sector, and we have this another triangle. Clearly, they are of different size. Okay. So it looks kind of like this. We know that the area of this triangle is less than this sector, which is less than this. But before we begin, this is a 1/2 base times the height. That's how you find the area of the triangle. But this is the area of the sector. In case you didn't know, consider that this is a theta and this is r radius. I think I'm gonna boo-boo. Hold on a second there. Of the radius r, that would be 1/2 theta r squared. Okay, and let's do the calculations, shall we? Here we go. For this one, it is 1/2. The base length, which is this one, is equal to 1, and the height over here is sine of theta h, which is less than, by the way. This is 1/2 theta r squared. The theta here, that's the h that we were talking about earlier, right? That's 1/2 h of r squared, which is 1 squared, less than. This is 1/2. The base here is same 1. This height, as turns out, is tangent of h. So we all have halves in common. So we essentially end up with sine of h less than tangent of h. Let us divide every single term by sine of h. Then we end up with 1 over cosine. But we don't want h over sine of h. We want sine of h over h. So we flip it. And we end up with this. Okay. For those of you who are a little stuck on step from here to here, think about this for a second. If you have 1/2 is greater than 1/3, if I flip the fraction, that becomes a 3, that becomes a 2, which goes this way, right? Another way to think about that is when you cross and multiply over here, what do you get? 2 is less than 3. That's two different ways of thinking about that. So putting that together, this is what we end up with. Now, here is the question for you guys, right? So what happens, guys? What is the limit? Limit as h goes to 0 of cosine of h is 1, isn't it? And the limit as h goes to 0 of 1 is just 1. So sine of h over h has to be in between those two values. So this is known as a by squeeze theorem, because two values, one is less than, the other one's greater than, and they're both going to the same value. So sine of h over h is being squeezed into that value. So by squeeze theorem, sine of h over h has to equal to 1. Sorry, the limit as h goes to 0. Okie dokie, guys. Yeah, that was it. So we end up with this expression. And now when you see this picture, you can see the reason why. Thanks for watching.